Right now, thousands of weather balloons are floating through the atmosphere, satellites are scanning the planet from space, and supercomputers are crunching quadrillions of calculations, all to answer one question: what will the weather be like tomorrow? This is the largest predictive system ever built, and it's way more insane than you think. Here's what's wild. A 7-day weather forecast today is as accurate as a 3-day forecast was 20 years ago. That's not luck. It's the result of a hidden global network that collects more data every day than almost any other system on Earth. And it's not just about rain or shine. It's about predicting hurricanes, droughts, and climate patterns, events that affect billions of lives. Let me show you how this works. Every day, weather agencies launch 1,600 weather balloons. These balloons rise 20 miles into the atmosphere, collecting temperature, humidity, and pressure data every few seconds. They transmit this data back to ground stations in real time. But that's just the beginning. There are also 11,000 weather stations on land, 7,000 ships and buoys at sea, 100+ weather satellites in orbit, and thousands of commercial aircraft that report atmospheric data mid-flight. All this data, billions of data points per day, is fed into supercomputers. The top weather supercomputers can perform 20 petaflops. That's 20 quadrillion calculations per second. These machines run numerical weather prediction models, which simulate the atmosphere as a 3D grid of cubes. Each cube represents a small section of the atmosphere, and the computer calculates how energy, moisture, and air move between cubes. But here's the insane part. The atmosphere is chaotic. Tiny changes, like a butterfly flapping its wings, can cascade into massive differences. This is called the butterfly effect, and it's why weather prediction is so hard. So how do they deal with chaos? Ensemble forecasting. Instead of running one simulation, supercomputers run dozens of simulations with slightly different starting conditions. Then they compare the results. If most simulations agree, confidence is high. If they diverge, uncertainty is high. This is why forecasts include probability. 70% chance of rain means 7 out of 10 simulations predicted rain. And the data sources? They're globally coordinated. The World Meteorological Organization has 193 member countries that share weather data in real time. A hurricane forming off the coast of Africa is tracked by satellites, monitored by US and European weather agencies, and modeled by supercomputers on multiple continents, all simultaneously. But there are hidden limitations. Weather satellites have blind spots. The Southern Ocean has almost no weather stations. And supercomputers can only model the atmosphere at limited resolution, usually 10 to 20 kilometer grids. Anything smaller, like a tornado, requires localized radar and human forecasters. Here's the real power of this system. It saves lives. Hurricane warnings give people days to evacuate. Tornado warnings give minutes to take shelter. Drought predictions help farmers plan crops. The system doesn't just predict weather, it prevents disasters. But it's also becoming more critical as climate changes. Extreme weather is more frequent and more intense. Hurricanes are stronger. Heat waves last longer. The system is being pushed to predict events it's never seen before. And there's a hidden arms race. Countries are investing billions in better satellites, faster supercomputers, and more sophisticated models. Weather prediction is national security. Accurate forecasts mean better military planning, agriculture, and disaster response. So what's the lesson? Weather prediction is proof that data plus computing power can predict chaotic systems. It's not perfect, but it's improving exponentially. And the more data we collect, the further into the future we can see. Next time you check the weather forecast, remember, you're looking at the output of thousands of sensors, dozens of satellites, and supercomputers running quadrillions of calculations. That's not magic. That's the most advanced predictive system humanity has ever built.